Introduction. The construction sector is facing demands for structural innovation in terms of digital dematerialization in managing transformation processes from the building to the territory. Demands for simplification and transparency in process information management and the rationalization and optimization of a very fragmented and splintered process are a key driver for digitization. In this regard, there are a number of elements that highlight the need to focus on digitization. The digital transformation of EU business and society presents enormous growth potential for Europe. European industry can build on its strengths in advanced digital technologies and its strong presence in traditional sectors to seize the range of opportunities that technologies such as the Internet of Things, big data, advanced manufacturing, robotics, 3D printing, blockchain technologies and artificial intelligence offer. This will enable our industry to capture a share in the emerging markets for the products and services of the future. The European directives for public procurement are pushing the entire construction supply chain towards radical transformation over the next few years, requiring research, development and training for digitalization. The private sector is also being greatly affected by demands from purchasing at an international level, which very often requires the use of BIM, particularly for large-scale operations. ICT standardization and interoperability are a precondition for the uptake of digital innovations. The challenge is to develop and ensure the adoption of European standards that ensure compatibility between systems and guarantee the competitiveness of the European industry and the openness of ICT markets. Then, standardization activity is very important in order to transfer research results to actual application. At the start of the 21st century, the acronym BIM was not well known as nowadays. Though, while the academy and the researchers were talking in the wider terms of ICTC, Information and Communication Technologies for Construction, the industry started introducing the new terms of BIM, Building Information Model or Modeling, to progressively substitute the words CAD, Computer-Aided Design, that, despite being already exhaustive of a decisional and management process supported by computers, and this is evident when referring to the way the mechanic industry implemented CAD to support its production process management, was still interpreted, by the majority of the players in the building industry, in a reductive way as CAD, or computer-aided drafting. The building constructions field, at that time is not mature yet to understand the potential of the computer-aided design as a decisional tool to support the whole construction process. The roots of the modern interpretation of the CAD and BIM systems can actually be traced back to the early 60s and to the activities developed inside the MIT labs of the Boston University. Many of the concepts still at the base of the modern CAD BIM software, such as software user interactivity, modular design, object-oriented modeling. Similar to other sectors, construction is now seeing its own digital revolution, having previously benefited from only modest productivity improvements. Building information modeling, BIM, is being adopted rapidly by different parts of the value chain as a strategic tool to deliver cost savings, productivity and operations efficiencies, improved infrastructure quality and better environmental performance. The use of BIM software has allowed users to simplify the entire project development in its entirety, especially for new buildings. This great change in the building construction is characterized by the opportunity to manage the whole process with a single tool in a clear and transparent manner. The data can be modified in real time by anyone who is licensed, appointing party and appointed party. Therefore, research in this specific area aims to develop interoperable and integrated methods and ICT tools to manage the various phases in the process of transforming the environment. In the different parts, the most relevant research activities in this sector are presented, focusing on the development of methods and interoperable and integrated ICT tools for the management of the different stages of the process for the transformation of the built environment. 1. Interoperable management of the process. 2. Design stage. 3. Executive stage. 4. Management stage. 5. Methods and tools for the condition assessment survey. The Part 1 presents a set of research activities, focused on the development of methods and tools, for the management of information and communication technologies through the whole process. The Part 2 presents an overview of various research activities developed in order to support designers and clients in the first design stages, in the framework of progressive digital transformation and BIM introduction. A new design approach is changing the traditional one with the introduction of building information modeling, allowing then to anticipate choices, preventing mistakes, pathologies and useless loss of time and economic troubles. Part 3 introduces the main research results useful for the optimization of production and construction activities, where the supply chain is involved. The Part 4 is aimed to present the most relevant research results of the digital transformation about the management of existing buildings, in general and for historical heritage. The facility management, FM, sector is undergoing a profound transformation of practices, processes, tools and references due to the adoption of novel information and communication technology, ICT, solutions which nowadays promise to improve the traditionally conceived FM streamlining processes, making new knowledge bases available to support data-driven decision-making processes and embracing a network approach to stakeholder management. The Part 5 describes the outcomes of some relevant research activities related to digital survey technologies of the built environment at different territorial scales, from that of large historical monuments to that of their surroundings and landscape. Specifically, the case histories of the Cathedral of Milan, Duomo di Milano, and St. Mark's Basilica, Basilica di San Marco, in Venice describe the technical development of the digital survey techniques for cultural and historical heritage during the last decade. The synergy of traditional and cutting-edge survey approaches made possible to build a digital replica of two of the most famous churches in the world, which are today used for both documentation and conservation of these exceptional monuments. Bruno Doniati, Marco Gianinetto,